Okay. So, last class I think we discussed about ARP and RARP, right? So, that portion I think we completed, and today we'll be discussing about IP datagram. Okay. Those who missed the class, don't worry. I will be repeating this class, and if you have any doubt, then you can also clear the doubt in the next class, and in our next class. So, as I think we discussed about IP and TCP/IP, right, in earlier classes. So, I think you all know the difference between the IP and TCP/IP, right? So, actually, what is IP? IP means what? Internet protocol, right? So, IP has some functions. So can you tell me what are the functions, or you can say some characteristics of IP, means internet protocol? Okay, I will tell you. First, I can say that IP means internet protocol is unreliable and it is connectionless. Okay, this thing I think we already discussed. Anyway, I am just repeating for once. So, what is unreliable? Unreliable means what? Why we say that IP is unreliable? Because IP does not provide a guarantee. It doesn't guarantee that a datagram or a message that you send from the source computer to the destination computer, that it will arrive at the destination. But it will always give the best effort delivery mechanism, means from his side he will give the best effort, but it doesn't guarantee that that message is received at the receiver side. Clear? So that's why it is we call is what unreliable. Okay. Now why it is called as connectionless? It is known as connectionless because what happened when sometimes when we make phone calls to some other, what happened after we dial the number, first what we did, we first dial the number and two of the people start talking or start speaking. Hello, hello, am I audible, right? Just wait. Okay, so what I'm talking about, first, IP is unreliable. Unreliable means what? It always provide the best effort delivery mechanism, but it doesn't guarantee that your message is received at the receiver end. Next one is IP is connectionless. Now connectionless means what? Suppose we give the example of phone calls. In phone calls, what we did, first we dial the number and after that we start speaking. Means what? First we establish the connection and after that we start speaking. Okay, means that is known as connection oriented. Oriented means what? First you establish the connection and after that you start talking. But in case of IP, what you did is that you directly sent a datagram and it doesn't require any connection to set up between the sender and the receiver before the datagram is transmitted. Okay, means what? Any computer can send message to the other computer at any time with no regards to other computer on the internet. As we can give the example of our mail. In mail, when you send a mail to your friend or to anyone, it doesn't require any connection, right? But just you send the mail. But yeah, when at the receiver end, it need the internet connection. But at the time when you send the mail, you can easily send it. It doesn't require that the other person should have the internet, or if he has the internet, then only you can send the mail. It doesn't like that. Okay, so these are some characteristics of IP, internet protocol. So today we are talking about IP datagram. Let me share my screen, just wait. Suppose this one is a computer, okay, and this one is again a computer, okay, and suppose this one is router, okay. Suppose this one is network. Suppose this one is network 2 and this one is network 1. And here again you have some computers, right? Again, let's take here, there are some routers, okay, and suppose this is again another network. Suppose let's take this one is network 3, and it has also some computers connected with this network, right? So what happened? Suppose these two are computers, right? These two are computers, and this one is suppose network 1. Suppose any kind of network you can imagine. This one, suppose this one is Ethernet network, and through this Ethernet network or this N1 network is connected to, suppose this one A computer and this one B computer, right? And after that the message is passed through the router and it will pass to another network. Suppose this one is another network, and two computers is connected with that network, and again this one is another router, and again this one is another network, and two computers are connected to this network, right? So suppose, let us assume that there are here how many networks are there? N1, N2 and N3. Okay, means we have three networks. And how many computers are there? In N1 network we have two computers, in N2 network we have two computers connected, and in N3 network we have two computers connected. So each one has a frame format that is recognized within the network. Means what? N network has its own frame size, means when a message is passed through this N1 network, the message should be the according to the N1 network frame size. Okay, and after that, if that message is passed through this N2 network, that message will be according to the N2 frame size. Okay, means what I can say, I want to say that when a message is passed through different networks, okay, So that message is fragmented, or that message is split into according to the size of the network. Means each network has its own frame size. Means when a message pass through a particular network, that message should be in the um, frame size according to that network. I think this portion is clear. Means the size and the format of this frame are obviously different, because N1 network has is a different frame size and N2 network has is different frame size. It is the address of a particular, no, it is not the address of a particular device. It is not the address. Address means what? When you send a message from the source to destination, their address should be there. Address should be there in the message. We're talking about the datagram, means the message. When you send a message from source to destination, that message is fragmented according to the network. Means when that message is passed through a particular network, so that message and that message is fragmented according to the network. Means suppose in N1 network, when a message is passed to N1 network, suppose this is the format. Suppose like that. This is an example. Okay, I'm just giving. Suppose here the source address will be there, and here suppose the destination will be there. Here some headers will be there. Okay, and suppose this is of 3 byte. Headers would be of 3 byte. This is of something 4 byte, and something like this. This is just an example. Okay, suppose again similarly, if this message is passed through this N2 network, it has different sizes. Here I think here maybe the header size is 5. Means what I'm just wanted to say is that particular network has its own frame size. Means when a message or when a datagram, we call say a datagram, pass through that particular network, that datagram should be in the format of that particular network. Clear? See, suppose this one is A and suppose this one is Z. Okay, suppose this one is A computer and suppose this one is Z computer. Okay, suppose when you want to send a message, ma'am, why it is not the same? See, that's what the what we call say the critical role. That's what the critical load. Suppose we are using LAN network, we have different frame size. Suppose someone is using Ethernet network, they are different frame size. Suppose they were using token ring network, that network has different frame size. So our thing is that whenever is message sent from the source to destination, a what we can say, there are some format. According to the format, we have to deal with the datagram. Okay, I'm just explaining you. Just wait and let me complete it. Okay. First, suppose we want to send a message from A to Z. Okay, from A computer to Z computer. Now, A computer is in a N1 network and Z computer is in N3 network. So, two are separate networks. So, their frame size will be also different. Right? So how can we achieve that the network and their frame format are different? Okay. So as here we can see that there is a vast difference not only in between the sizes of the frame or the datagram format, but also between the individual field length and content. Now the question is, in which format should we communicate? Should the communication take place? So here the IP plays a major role. Okay, it means Internet Protocol. IP plays a major role. Now, what are the major role? Just wait. Up to here, I think this one is clear. Suppose you want to send a message from A to Z. These two networks are completely different. So our challenge is that how we communicate or how we send a message from A computer to Z computer, because all the networks are different. So here come the internet protocol. Yeah. So I'm just giving you the structure of the format or of the IP datagram. Means what is IP datagram? Here a message is broken down into some multiple datagram. Okay. Again, some suppose. Just wait. Let me erase this. Suppose this one is message. Okay, suppose this one is message. So this message is broken into multiple datagram, like this way or like this way. Okay, into multiple datagram, and a datagram in turn can be fragmented into different fragment. Okay, means this one is, suppose this one is datagram and this one is datagram. Okay, and this datagram is again fragment means divide. Okay, this datagram is again fragment into multiple datagram. Okay, according to the depending on the frame size, how many frame size we required, and depending on that a message is fragmented. Okay. Just wait, I will share my screen, then it will be easy for you. Okay. Just- As I think you can see my screen.